Oops. Hello, everyone. Thank you so much for joining. We are going to get started in 5 minutes. I'll make my little note. Okay. Hello, everyone. Thank you so much for joining in today. We will start in about 1 minute. If you have any questions, please email your homework questions to homework@systemtutoring.com. All right. Thank you everyone for joining. If you're on TikTok, great to see you. Great to have you here. I hope you're having a phenomenal day. I know I am. It's 4:35 where I am. I don't know where you're at, but wherever you're at, go ahead and put it in the chat. Let me know where you're from. I am from Houston, Texas. And I'm just so excited to be here. So today's about chemistry, and if you have any questions about chemistry, please feel free to send an email. So I put the email here, homework@systemtutoring.com, and I would love to answer any questions that you might have. It looks like I'm having a little glitch on my what's it called? My thing here. So let me just go ahead and refresh it, and let's see if that helps. Okay, that should be good. If anything glitches, just let me know, no problem. But yeah, for now I am here and we can get started. Sorry, there we go. All right, I think it glitched a little bit, but we're good now. Okay, so today we are gonna be going over stoichiometry. Stoichiometry is really fun, really, because it's kind of the building blocks of chemistry. So if you are having a bit of trouble with stoichiometry, or you're having some trouble with just balancing equations and things of that nature, this kind of lesson is for you. You can definitely ask any other questions. You can shoot me an email, as you can see on the screen here, homework@systemtutoring.com, and I'd love to help you. I'm checking my email now. Give me a second to see if any questions have come in while I've been talking. Let's see. It looks like there are no questions, which is totally fine. All right, so what I'm gonna try and do is, okay, let's do this one. All right, so we're just gonna jump right in. We're talking about stoichiometry. So stoichiometry is just the balancing of equations to figure out how many moles something has, what the molar mass is, and it's just a quick and easy way to figure that particular calculation out. So some questions that would require you to know a little bit about stoichiometry is when they ask you, how many moles of this element is present in this compound, or how many moles of this compound is required to make this many moles of reactant. It just depends on the question. Sometimes they even go a step further and they'll ask anything about grams. They'll say, okay, we have this many moles of this compound, how many grams are present? So you have to know that there is a mathematical formula or process to figure out and balance out equations accordingly to get to your final answer. So in this particular question, this one is saying hydrogen sulfide. So I'll try to write small so we have room. So they're just saying hydrogen sulfide is converted to sulfur dioxide in the atmosphere. And so they tell me that this is the reaction. Okay, so they say the reaction is 2H2S, which is hydrogen sulfide, and it's going to react with the atmosphere or oxygen. Oh, and let me do something so we're clear about what these are. This is a gas. It's going to react with oxygen, which is also a gas. And then it's going to yield 2SO2, which is a gas. plus 2H2O, which is a liquid. And to make sure we can see that well, they do like a cursive L. All right, so this is our formula. Uh-oh. Is this showing? Like it's a little laggy. That's all right. Okay, so we can go ahead and continue on here. So this is our formula for hydrogen sulfide converting to sulfur dioxide in the atmosphere. Sulfur dioxide is going to be 2SO2 here. And so the question is asking how many moles of H2S are required to form 8.2 moles of SO2. So let me just put the question here. To form 8.2 moles of sulfur dioxide. So this is the question. Take a moment and let that digest. While that's happening, let me see if there's any questions. Oh, is my screen frozen? Let's see. Okay. I think we're okay. Let me see if there's anything in the chat. So far, no chat. Let me do something. Okay. All right. Let me just take 1 second. I think there might be a glitch in the system. Okay. All right. I don't know what was happening. There was a bit of a glitch, but I think I fixed it. If you see that let me fix my face too. Let me just fix that. Okay, let's see. Did that help? I think so. Okay, cool. I'm sorry, y'all. There was a bit of a glitch, but I can go back and explain everything in a moment. Okay, I'm making myself smaller so you can actually see the question. All right, we're good. We're back on track. Technology, right? Okay, so in this question, we are going over we're going over stoichiometry. And the question is, hydrogen sulfide is converted to sulfur dioxide in the atmosphere. I think I kind of went over that. The formula we have is here, 2H2S plus 3O2, which is a gas. These are both gases, and they react and they form 2SO2 and 2H2O. So that's water and sulfur dioxide. So this is the chemical formula or makeup here. And the question that they're asking is how many moles of H2S are required to form 8.2 moles of SO2? So that's kind of where we left off. I apologize for any confusion that I may have caused. But in any type of chemistry problem, don't stress yourself out. All you need to do is you need to figure out what have they given me. So I like to use a different color just so you can see and start with what have they given me? They have given me 8.2 moles of SO2. This is something that has already been provided in the problem. Very important, start there. And just write that down. So 8.2 moles of SO2, oops. And when you write moles as, you can put MOL, you don't have to write the full word. So 8 moles of SO2 looks like this. And then the question that they're asking is, they want to know how many, so I'll make this in a circle, how many moles of H2S are required. So that's what we're trying to figure out. And it's super simple. We set it up in a really, really easy way, and I'll show you exactly how to do it. So once I have my moles, all I need to do is dimensional analysis. Dimensional analysis tells me that I need to compare ratios or compare, ratios, or formulas that I already kind of know. And when I say that, you're probably a little bit confused, but it'll make sense in a moment. So when I do this problem, I'm gonna do times and I'm gonna create a fraction. That's because I'm gonna do dimensional analysis. And when you do dimensional analysis, you're trying to get rid of stuff to get to your answer. And so in this particular question, moles of SO2 has been given to us. That's what we're starting with. And you can think of it as being over a fraction. So you can think of it as this being over a 1. Whatever that 1 is, we don't really care. But we know that any number that stands alone can be divided by 1, and it's still the same number. It doesn't matter. So in this particular question, because the moles of SO2 are in the top half or the numerator of the fraction, we want to get rid of that because we somehow at the very end, we want to get to H2S, right? We want to get to moles of H2S. And we don't know what that is yet. So to get rid of moles of SO2, you can just put it in the bottom of your next fraction. Okay? We're not going to cancel anything yet, but this is where you need stoichiometry, or you need to kind of think about some of the ratios or some of the problems that you have. So here in this question, it's telling you that they gave you a formula for a reason, and they're giving you moles. There is a comparison, or there's a ratio of moles of SO2 to moles of H2S in the actual problem. And I'm not sure if you can see it, but it's right here. There are 2 moles of H2S to 2 moles of SO2. That is a mole-to-mole ratio that you can leverage here in this problem. So what I'm going to do then is put my moles of H2S here because I see there's a comparison or a ratio. And I can see that this is 2 to 2 in the equation. Now in my head, I can say, okay, I no longer need moles because those moles are now canceled out because moles of moles of SO2 can be canceled out because you now have 2 of them. So now I can go ahead and the one in the top and one in the bottom, I can just do this math. So to do this math, you can use a calculator or you can use your phone, whichever device that you may have. And you're just going to multiply the top and then divide by the bottom. Sorry, having a bit of problems with the thing. Okay, so now what I'm gonna do is 8.2 times 2. I'm just gonna scroll down because my calculator died. So if I scroll down here and just do that math, I can just do it here. So 8.2 times 2. And please let me know in the chat if there's any issues. I know I'm having a bit of glitches on my end, but I think we're okay for now. I just want to make sure. Let's see. Okay, so no complaints yet. So 8.2 times 2 will give you 16.4. And then obviously, if you divide that by 2 again, you should go back to 8.2. So it looks like there are, to make 8.2 mole, to form 8.2 moles of SO2, you also need 8.2 moles of H2S. Cool. Let me check and see if there are any questions. Okay, I don't see any in the chat. Let me check my email. All right, no questions. I guess I'm doing a great job. If you ever need me to stop or slow down, I'm more than happy to. Okay, I'm gonna erase this because we have another question, and this one is saying how many moles, or how many grams, sorry, of oxygen are required to react with 1 mole of H2S. Okay, same as before, we're going to start with what we have. So what we have, I always like to use like a bright color, is 1 mole of H2S. So we'll go ahead and start with that, 1 mole of H2S. And I'll pull this down a little bit so we can see it. And we need our dimensional analysis. So I'm gonna always put this over 1. And then I have my next fraction, which I'm not sure we'll go there yet. But this one is also gonna be a mole to mole ratio to start. So the goal is we somehow need to get to grams of O2. So this is what we are looking for, okay? So I'll put my mole, I'll make this smaller so we have more room. I think I'll need more room. So we'll have moles of H2S on the bottom because again, we want to get rid of it, right? And then don't forget that there's a mole to mole ratio here with H2S again. So it's 2, sorry, in the equation, it's 2 H2S to 3 O2s. So I can write that. So there are 3 moles of O2s to 2 moles of H2S in our problem. All right, we're still not done yet because although these are gone, we're still stuck here. And the question is not asking for moles, it's asking for grams. So we continue. We have to get somehow to grams. At the very end here, we need to have grams of O2. Okay? We're only at moles now. So we want to get rid of moles somehow. We put it on the bottom because right now it's in the top half of our fraction. And so this is where it gets fun. We've been doing mole to mole ratios, but you can actually also do moles to grams as well. And that's called molar mass. So if you're not sure what molar mass is, I can write it off here as a note. Molar mass is equal to moles to grams, or moles slash grams, make it easier for you. The number, sorry, not moles to grams, it's the grams per mole. That's molar mass. All right, so there's a molar mass comparison here that we can use, and it's going to be the grams in the top of O2 compared to the moles of O2. So 1 mole of O2 is equal to a certain amount of grams. If you are not sure what that is, all you need to do is go to your periodic table. So I will do that. I'll open up my periodic table. And once I open it up, I'll look for oxygen. Oops, that doesn't show me much. Let me actually open up one that gives me mass. So open up a periodic table. I hope you can see this. And I found oxygen here. And it looks like 1 mole of oxygen on our periodic table is always going to be 16 grams. All right, so let me go back to my sheet. And this question is asking for 1 mole of O2. What we saw on our graph or on our periodic table is 1 mole of just 1 O. This is O2. So if 1 mole of O2, of O, just oxygen, is 15.99999 grams, that means 1 mole of O2 should just be double that, right? Because we have 2 of them. So we're gonna have about, I think it's 32.00 something. So we can just round it to 32 grams of O2. Do I have a question? Let me check. Okay, no questions. Cool. All right, so continuing on here. I think everyone can see. Oh, you can't see the bottom, that's why. Okay, let me scroll down a little bit. There we go. So 32 grams of O2, we're just gonna do that math. So we're gonna go across and we're just gonna do 3 times 32, and then you're gonna divide by the bottom, which is 2. So we should know that 32 times 3 is going to be 96. So we can say equals 96. We're going to divide that by the 2 here. And when you do that, you should get 48. 96 divided by 2 is 48. So your final answer is 48 grams of O2. You need 48 grams of oxygen gas to react with 1 mole of H2S. All right, let's see if there's any questions. Okay, I'm not seeing any questions in the chat. Let me check. Okay, no questions in the email, totally fine. Let's continue on. So our next question then is even more fun. And it's asking how many grams of water are produced from 6.82 grams of H2S. Okay, so we're starting here. Don't forget, you always circle or box what you start with or what they've given you. And they've given you 6.82 grams of H2S. So I'm just gonna go off to the side here and write it out. I'm gonna also make my fraction. There's a 1 here, imaginary 1, and then we'll start there. I know automatically I need to have a grams of H2S down here because I need to get that out of there eventually by dividing. But without thinking about it too hard, I need to figure out what would go in the top. Actually, what am I even looking for? So this question is asking me how many grams of water are produced when I have 6.82 grams of H2S. So I could scroll up all I want, right? Let me scroll up. And I see that in my equation or my formula, it doesn't tell me anything about grams, right? It tells me stuff about moles. It tells me that there's a gas. It tells me the reactants, fine. But it doesn't tell me anything about gas. So nothing about grams. So I'm not going to be able to do anything here with this equation. I'll come back to it, but I need to figure out exactly how or what goes here. I know at the very end, though, you can write it off at the very end, I need to figure out grams of H2O. This is what I'm missing, okay? So I can't do grams to grams. There's no such thing as a grams to grams ratio. Does anyone know, because I see there are 3 people watching, does anyone know what ratio or what comparison or what analysis I will use to go from grams of H2S? What goes in the top here? I think we just talked about it earlier. It's somewhere on my page and it's written in yellow. Anyone? Anyone at all? No one wants to answer? That's all right. No worries. So grams of H2S is we're going to use molar mass again. Okay, we're going to use molar mass because we can go from grams of H2S to moles of H2S, just the reverse, right? So we know 1 mole of H2S will equal grams of H2S. So to find out what that is again, we just use our periodic table, right? So we have 2 hydrogens. So 1 hydrogen is 1. 2 of them would be 2, right? Just add them together. 1 plus 1 is 2. But then we have S, which is sulfur. Let's look for it on the periodic table. It's over here, and it's 32. Okay? So sulfur is 32, and 2 hydrogens are 2. So it looks like we're about a total of what? 34 grams of H2S. All right. We're not finished yet, though. However, we do know we are no longer dealing with grams of H2S. We're now moving on to moles. Don't forget moles of H2S. Sorry. Don't forget moles of H2S will go down here. And here is where we can use our mole to mole ratio, right? So we're somehow going to get to moles of H2O. We know that right off the bat. If I scroll up, it looks like in this case, we have 2 H2S to 2 waters. Cool. So I'm going to go back down. 2 moles of H2O, 2 moles of H2S based on our problem. Okay. All right. So from here, we're still not done. I think we need more room. So let me actually bring this down a little bit. Let's continue. So here we can go from moles of H2O, because we want to get to grams, somewhere down here. So we have moles of H2O, and then we can again use our molar mass comparison. So our molar mass comparison is going to be grams of H2O. Same thing here, 1 mole of H2O is going to equal some grams of H2O. What is that? No problem, we go to our periodic table. Again, we know H2O has 2 hydrogens. 1 hydrogen is worth 1 gram, and then another one is worth another 1, so that's 2. And then we go all the way across to oxygen because we have H2O. And then again, that one is 16. So 16 plus 2 is 18. All right, so what do we do here? Multiply the entire top, and then you divide by the bottom. Okay, so when we do that, 6.82 times 2 times 18. I'm doing it in my calculator. So I did the entire top. I got 245.52. And then I'm going to divide that by the bottom, which is just 34. It's going to be 1 times 34 times 2 times 1. And when I do that, I can do that in my head. That's going to be 68. So 245.52 divided by 68. Let's see what that is. And that is 3.61. Or 3.6, whichever one that you got. You can round it up or keep it. I'm rounding it up. So the question asks, how many grams of water are produced from 6.82 grams of sulfur dioxide? Or sorry, hydrogen sulfide, sorry. And it's 3.61 grams. All right. Let's move on to the next question. But before I do, let me check if there are any questions in the chat. Looks like we are okay. No questions so far. Okay. So the next question says, if 12 grams of SO2 are formed when 7.98 grams, or formed from, I'm sorry, not when, are formed from 7.98 grams of H2S, what is the percent yield? So you're probably wondering, what in the world are you even talking about? And all you need to know is that this question is trying to figure out if you understand what percent yield is, if you even understand stoichiometry. So percent yield is just a formula, and that formula is this. It's how much is available when you take the actual amount and you divide it by the theoretical amount. And then you obviously need a percent, so you multiply everything by 100. So this is the formula we're gonna need. But before we even go there, we need to figure out some things. It's asking about SO2. So please be careful. When you're looking at this question, there's a lot going on a little bit. They're asking if 12 grams of SO2 are formed from 7.98 grams of H2S, what is the percent yield? The part you're not seeing is that they're asking about the percent yield of SO2. So if they're asking about that, you want to actually be mindful when you're going to go and do your problems. We want to figure out how much is formed from 7.98 grams of H2S. We have two givens here, right? Because normally we just box the given in a green, but we have two of them here. You have to still think on your toes. You might be tempted to start with your 12 grams of SO2, but that's not what you're actually looking for. That's not what they're actually giving you. This is important. This 12 grams is important when we try to figure out what the what the percent yield is, okay? So they're telling us that from 7.98 grams of H2S, this is where you want to start. Because from here, you'll figure out what the theoretical yield is from the 7.98 of SO2, and then you can calculate the percent yield. Let me show you what I mean. So we're gonna start with 7.98 grams of H2S. I think we have a good handle on how to do stoichiometry. So we put our imaginary 1 on the bottom, multiply that by another fraction. We know we need to get rid of the H2S somehow. And we know that when we have grams, we can do a moles to grams ratio, which is called molar mass. So when I do this, 1 mole of H2S, I think we did it above here, was 34 grams, okay? We keep going. We know we're no longer dealing with grams of H2S, we only have moles of H2S left. We make another fraction. We put our moles of H2S on the bottom. And we can do now a mole to mole ratio because we know that based on our problem or our chemical formula, that there is a mole to mole ratio. How do we know what that is? Just scroll all the way up. So we've done a bunch of problems here today. And we look at our chemical formula and we try to figure out, okay, what is the ratio of moles of SO2 to H2S? And again, we see that it's 2 H2S to 2 SO2. We also saw it above in the earlier problems. So I'm gonna scroll all the way back down. Okay, so we know this is 2 to 2. And then we're not stopping there yet because guess what? We no longer are dealing with moles of H2S. We're now only with moles of SO2. We don't want moles. We want to get to grams somehow, right? So we can do that. Sorry, I'm gonna use my black or my dark blue by creating another fraction. And on the bottom of this fraction, we'll have our moles of SO2 to our grams of SO2, which again is a molar mass calculation. So in the bottom, we'll have 1. That's 1 mole of SO2. If you don't know the molar mass of SO2, you're not supposed to know it by heart. You head over to your handy dandy periodic table right here, and let's figure it out. It looks like we have sulfur and oxygen all in the same space. Perfect. We have 32 grams of sulfur because we have 1 of them. And then 1 oxygen is 15.99. You can round that up to 16. But you have 2 oxygens, so you have to do 2 of them. So 16 times 2 is 32. So technically, if we go back to our problem, we have a total of 64 grams of SO2. 1 mole of SO2 is 64 grams. Okay, so now we're gonna do this math. I ran out of room and that's okay. I'm no longer dealing with moles. I'm now at grams of SO2. And so we'll just use a calculator and multiply the entire top. So I'm gonna do these, 7.98 times 1 times 2 times 64. Okay, and that gives me 1,021. I'll make this so you can see it better too. Oh, I ran out of room. Oh well. Okay, 102.144, and we're gonna divide that by the bottom, and the bottom is 1 times 34 times 2 times 1. And if you do that math, you should get 68. So 1,021.44 divided by 68. When you divide that, you should get 15. Let me know if you do. Okay. So we got 15 grams of SO2, but this is still not our final answer because they're asking for the percent yield. I ran out of room here, so I'm gonna move on to the next page. And don't forget that the percent yield formula is equal to actual over theoretical, and you multiply that by 100. So in our question, we had 12 grams of SO2. When we did all the math, we got 15 grams of SO2. You need to be able to tell which one is actual and which one is theoretical. And so actual is actually going to be, I know I'm using the word twice, is 12 grams, because they're telling you that 12 grams formed from the 7.98 grams of HUS. But they're asking you, theoretically, when you do the math, which we did, this dimensional analysis down here, you're actually supposed to get 15, right? So theoretically, you're supposed to get 15, but you actually got 12. So that should tell you that when you do your percent yield, all you're gonna do is the top is 12 grams of SO2, and the bottom is your theoretical, and that one's 15 grams of SO2. You multiply all that by 100, and so your percent yield equals 12, 15, that's gonna be 4/5, which is 80%. Cool. We are at time, so I'm not going to use up too much of your time here. I am going to come back in about 15 minutes, give or take, to go over physics. So if you're struggling with any physics homework, please join in about 15 minutes, and we can go over any problems. I'm here every week on Wednesdays for chemistry and physics. So please tune in every week if you can, if you have any questions. And if you're struggling with math, algebra, pre-cal, geometry, I also do that on Mondays. So please follow me here on Twitch, YouTube, TikTok, Instagram, wherever it might be, and tune in whenever you need any homework help. It's for free. Thank you, everyone.